Hey guys, welcome to Natural History Discussions for this week. This week we are really lucky because Cindy Yamamoto, the manager at the Hawaii Rare Plant Program Micropropagation Lab up at Lyon Arboretum, has agreed to give us a little tour and tell us about the program, which I was just telling her I thought should have, this is so important to natural history of Hawaii that it's really great that we're able to include it now. So welcome, Cindy. Thank you. And if you can just tell us what you do here and a little bit about where we are.
Hi, my name is Cindy Yamamoto, and this is the Hawaiian Rare Plant Program. The program actually started in 1998 with the founders being alarmed at the sudden increase in the decline of native Hawaiian endemic plant populations. And so it was determined that they would try to use micropropagation as a tool to kind of mitigate this. And the reason being that they would be able to store a whole lot of plants in a small amount of space. The micropropagation lab is
No, that's great. But while you're thinking, I was just gonna say, so micropropagation, if you can, if you could just tell them a little bit about what it is, and then they're gonna see about the sterility and everything when we go downstairs. But maybe important to let them know before you just tell them what it is, that tissue culture is a big tool for agricultural crops. And do you know, was it new to conservation when they started doing it for the Rare Plant Program here?
I believe it was new for conservation when they started doing it, although it had been in use commercially for many years before that.
Cool.
But as far as conservation, I think it was kind of new. And just the fact that we are I believe, only tissue culture lab in the state tells me that there aren't that many people that actually know how to do this type of work.
So what is it? Tell us, what is tissue culture?
So tissue culture is an aseptic technique where plant material is surface sterilized. They're brought into the laboratory and grown under artificial conditions with the nutrients they need to grow are put into glass test tubes or some kind of container and grown indoors under lights and a controlled environment. That way you can keep out many of the issues that you have growing plants outdoors, which is fungus, bacteria, too much rain, too much light, all these other environmental conditions that you don't have in a laboratory setting.
Great. So you're taking plants that are endangered somewhere in their natural habitat, and you're giving them a place in a test tube, literally, to grow away from all of pests and pathogens. Yeah.
Yes.
And okay. Sorry about that. So we had somebody come visit the lab, but right before the pause, I was saying, so basically you've got these plants which are endangered that you've surface sterilized and used a special technique and protocol to get established and living in test tubes. So my question was going to be, you guys, I assume, have to kind of baby them, kind of acclimatize them if and when they get planted back out in the wild in a restoration project. They can't, they're probably kind of soft, right? If they're living in a test tube and being protected from all those things.
Yes, so there is an acclimatization period where we put it through a specific protocol, and these plants are hardened off so that they can grow better and be better adjusted to the harsher living conditions of being in a greenhouse and being outdoors. And then they're grown on to an appropriate size that they can be used to outplant it, and then from there they hopefully will be put back in an area that they originated from, or under the same environmental conditions of an area that they normally grew in, so that they would have the best chance at growing successfully.
Cool, great. So before asked you about tissue culture, you were telling me about the program.
Yes, so the program is part of a network of conservation collaborators, and our part in the whole network is actually the propagation part. We have people that are the collectors who go out in the field, they manage these plants and monitor them. They bring the plant material into us, which is sometimes seeds or cuttings, and we process the plants, propagate them, and return them to the people who are responsible for the maintenance of these plants.
Wow. So, to recap, you make it sound very matter of fact, but really what you said is this is the main propagation facility for the state's network of different entities that are all monitoring all of the rarest plants in the whole state, and they're sending you that material, whether it's a cutting or seeds or fruits, and you guys get it going for them. And I know you work in conjunction with the seed lab here as well, and
Yeah.
wow.
So we work with the seed lab, and that the plants that can be stored through conventional methods in the under seed storage conditions are stored there, because that would be the most cost effective and less labor intensive way to store them. And the ones that cannot, for whatever reason, whether the plants are not able to be stored because they have some kind of issues where they're not storable, or they are received in a condition that makes it unable to be stored through conventional methods, they are propagated in our lab.
Right. And when you said the tissue culture is labor intensive, meaning that once you've got these things established in a test tube, you've got to continually monitor and maintain those
That's
cultures.
Right. Right. These plants are living plants, and as such, they do require nutrients to grow, and if they don't get replenished because it's a finite amount in a test tube, the plants will decline and eventually die.
Cool. Okay, well, you want to, maybe we can go downstairs and you can
Sure.
show me the rest of the lab and the cultures and everything down there?
Sure.
Cool, thanks.
Okay. So here we are in the kitchen area. This is where we do a lot of our media making and dishwashing. And we also have plant material that comes into the lab. It gets processed in this area here also. We have more storage now than we used to, so that's nice.
Yeah, nice lab. So what you're doing here, you said, is just processing the material when it comes in from outside. And since it's a aseptic lab, like you said, you're also then preparing all of the sterile media?
Yeah, cool. It gets prepared and dispensed, and then it will eventually be autoclaved. In the room here we have for the autoclaves, which is a heat room for all the things that generate a lot of heat.
Cool.
Because the media has to be aseptic.
Yeah, right.
Yes.
Wonderful. All right, let's check it out. Oh, so much nicer than the old lab.
Definitely.
So this is a whole room just for your media and for the autoclaves and cooking, huh?
Mm-hmm. All the heat generating equipment is all in this room, the microwaves and the refrigerators.
Awesome. All right.
So this is the main flasking room. This is where the work gets done 90% of the time in this room. The hoods are set up so that each person sits at a station, and the way the hoods work is there's a double filtration system, there's a pre-filter at the top, and there's a HEPA filter underneath, so the air that comes from outside gets filtered twice and comes out positively always this way.
Cool.
So that allows us to work on plants and keep them aseptic by putting the media and tools and everything in this one and having the airflow always going.
Wow. So you're working in sterilized air with, it looks like flame sterilized tools, and on the media that you just cooked in the autoclave. Very cool.
As well as paper towels that have been autoclaved to be sterilized so we can work on them also. So anything the plant comes in contact with needs to be aseptic so that we can
Interesting. So you're saying that once you've got the plants established and they're growing in the test tubes, that you got to make sure they stay sterile because it's a sugar-based medium and it's
Yes.
sterile. So if contaminant gets in there, it will actually like outcompete the plant.
Just like weeds grow faster than your plants,
Wow.
so does contamination grow faster than the plants. Yes.
Oh wow, very cool. So when you're talking about the maintenance of the cultures upstairs, it's not only expensive because as the plants are growing and using up their food, you need to change them, but you've also got to be skilled when you do it so that you don't introduce contaminants.
Right. So, and it takes a lot of man hours to maintain the plants that we do have in culture. So that's how we spend most of our time here is what we call subculturing, which is basically taking the plants out of the test tubes. We'll clean them up, cut them into a smaller piece, and put them back into a test tube with fresh media, and that way we can keep it going for many years.
So this is this a cyanea?
Yeah, Cyanea lobata.
All right. So and then this is cleaned up and we're just taking one nice shoot and put it onto some fresh food, and it's all sealed up and sterile. Wow. So it's also obviously you can see here. A great way to multiply your plant material, right? Because there's multiple different plantlets in there that you could separate out.
Yeah. And that's how you're able to clone many of the plants that we have. Yes.
Cool, awesome. Can we see the room?
Sure.
Cool.
Come this way.
Yeah.
So this is our main culture room.
Oh.
And in this room, we have over 30,000 plants. And they comprise about 200 native plant taxa,
Wow.
about half of which are federally listed as endangered or threatened. We also have culturally significant plants, such as taro
see that.
collection
Yeah,
here, you
kalo.
can see. And we also have some sweet potato varieties, and we have some banana varieties.
Very cool. We just had Dr. Pang, Benton Keali'i, lecturing, and he was showing us some of the kalo varieties like the Elapayo and the Oahi Apele, as well as talking about the importance of a number of different plants, everything from Calibrina to Musa. So very cool to now be able to show them that you folks up here at the lab are actually doing conservation work with these varieties of canoe plants like Mana Ele, Moana,
We have about 50, there's about 50 varieties that we
Moana
have
Ula
sorted.
Ula,
Mhm.
50 varieties. Wow. Nihopu'u, Manini, wow. Mana Laloa, cool. I know that Oahi Apele is my favorite.
Mhm.
Okay, cool. Is there any, you know, I hear all kinds of great stories from plant biologists in Hawaii, whether it's someone like Steve Perlman dangling off of a cliff pollinating something, or how some plant was saved. Is there any cool stories that come to mind in here or over the years working with these plants?
Well, there have been plants that have come through, some of which actually are no longer living in the wild. They're only existing in cultivation. Some of the plants actually were existing only in the lab and did get put back out in the wild. So we do have some like Cyanea and Grimsiana. Trying to think off the top of my head. There's
Truncata, is there a lot of
There's still Truncata, I think.
kahana?
Yeah. But yeah, there's
Wow.
a lot of plants that maybe they're not extinct in the wild, but there's so few of them that to have a viable population exist is really difficult. So those are the plants that are on the target species for us to try and build up populations for.
Wow.
And there's just so many in number.
Working with
enormously,
plants that are extinct in the wild. Wow. We had one lecturer earlier in the semester mentioned Kanaloa, Kaho'olavensis, that previously had apparently been a widespread fab species throughout the high islands, and you know, they didn't even know about it because it had essentially been extirpated from all but like one location on a little seamount off the coast of Molokai or something. So my question is, when you folks work with plants like that, which I know that you guys were heavily involved with, you know, working with that cuttings of that species, what do you do? How do you, quote unquote, experiment? What do you do? You can't just experiment and do trial and error with the last one. So what do you guys do?
It depends on the plant. It's a case by case thing. So if there is enough material that we are able to get it going in culture, and we usually try to have some plants come out so that you do have still representation ex situ, but also if we are able to secure enough material of the plant, then and if the person who is responsible for the monitoring of that plant wishes to try and, you know, propagate it more, we can try and experiment with different medias and different methodologies to try to increase the plant material that we have. But like I said, it depends on the plant and what the exit strategy is for that particular plant for the person who is responsible for it.
Wow. So, like, if there isn't enough material and you're just trying to figure out how to get, say, a finicky plant established, can you try and work on something closely related and try and work out a protocol?
Yes, we will try to research what has been done with sister plants or other plants in the same family sometimes, even maybe not in the same genus. But a lot of Hawaiian plants are endemic here, and so they don't have a whole lot of material information available about them, much less in tissue culture.
You're doing it, you're making it, huh?
Yeah, I'd like to think one of these days this information that we've garnered over the decades of research and working with these plants will be put into good use and actually published so that
I'm sure
everyone can, you know, gain from our research and what we've done so far. That would be ideal.
Yeah, you guys need a publishing wing while you all got your heads down just cranking out plants. Well, this is amazing. I think we have enough time to see if you, is it possible to get you to demo a plant
Sure.
being worked under that hood for us?
Sure.
Great, thanks.
Mm-hmm.
Okay guys, we are back in the transfer room, and Cindy has agreed to show us how this magical aseptic sterile test tube plant working goes. So she's got I'll kind of do a play-by-play while she does the work. So she's you know, got her hands are sterilized with alcohol. She's working under the hood, so all the air in there is sterile. She's using bleach and alcohol to, you can see, flame sterilize her tools. What you got, a mint?
Yep, this is a mint, Phyllostegia. It's part of the mint family, Lamiaceae.
And that's a native endemic species?
Yep,
Very cool.
Phyllostegia kaalaensis.
All right, so that's for you guys, you botanists out there, that's the species native to Mount Kaala. So what she's doing is she flame sterilized the tube before she opened it. She's using her sterile tools to pull the plant out of the tube, and she's being very careful not to touch the napkin or even really take her hands over top of it. So she's, with ease, you can see her just, you've done this before.
A few times.
She's cutting up the plant, and she made a nice new fresh little cutting, and again flame sterilizing her new media and plant food / house. right into that gel. Very cool. Awesome. And then, like, depending on what you're doing with that plant, if you needed, say, to make more, you could even cut up that thing and get another cutting out of it, yeah?
Yes, if I needed to take more, I could also do other cuttings and hope for axillary shoots to come out from the sides.
Awesome. Wow, that's really very cool. I guess that's all the questions I have. You know, I could go off into a bunch of different avenues, but I know that you've got a lot of plans to work.
Thanks for coming by.
Yeah, thanks a lot. If people are interested in learning about, you know, how to do this, or they want to volunteer here, do you guys accept volunteers?
Yeah, they can contact our education department and they will have them fill out a volunteer application online and we will be in contact with them.
Cool. So if anybody gets, they can just get in touch with me, and I'll give them, put them in touch with Ed, and once the Rona is over, they can come and learn how to tissue culture and maybe try how to save some native plants. Right on. Thanks, Cindy. I appreciate it.
Thanks for
Okay.
coming by.